So let me take a look at the matrix multiplication program that we discussed the last time. Let me open the video and then try to see what is it that we discussed here. So as I see, we took two matrices, as you can see, A and B, and then tried multiplying it and we got C, right? So I was trying to explain here that any entry here, let's say C11, is basically the dot product, what is called the dot product of two vectors. You see, the first row and first column gives you the first entry in C, the C11. Okay, we went ahead, we showed how we do the dot product, and then finally we get the answer, right? I've just opened the video and I'm trying to see how we explain matrix multiplication. I would like to redo the code right now, of course using functions. So we are trying to illustrate here that the ith row and the jth column results in Cij here. Cij simply is ith row of A, ith row, third row remains the same, but the columns change. Okay, first column, second column, third column, fourth column, fifth column. Of course, the first one is called the zeroth column. So 3, 0, 3, 1, 3, 2, and so on. Here we have second column, and then the rows keep changing. Okay, second column, first row, which is 0, 2 entry here, and 1, 2 entry here, and then 2, 2, 3, 2, 4, 2, and so on. So when you multiply these two things, what you get is the third row of A and the second column of B results in the entry C3, 2. Correct? That's what we explained. I will quickly go ahead. Just fast forwarding and seeing what I explained, basically the dot product, as you are able to see, and that's pretty much it. Very good. So we understood this part the last time. If you didn't, the mistake probably is mine because I probably did not explain it properly. So let's go ahead and then see what was the program that we tried writing the last time. Okay, so as I remember, we took this matrix A and B, right, and then we initialized C to all zeros, and then all that we did was, take the dot product of the ith row of A, as you can see here, and the jth column of B, and we assigned that to C of ij. And that's pretty much it. How did we do it? It was a very complicated process with some, for I in range dimension, j in range dimension, C of ij is dot product of A and B of j. I wrote that in English and then tried converting that to a function. You see, so I remember it was quite a long session of thinking and programming. So I get this, and that's pretty much it. 3 for loops, one within the other, and I print C and C comes here, and we even verified whether it is right or wrong, and we got 25, which was the first entry in C. Perfect. So far so good. Now we'll go ahead and we'll try to see if we can write the same piece of code the easy way. What do I mean by easy way? By easy way, I mean I'm not going to think as much as I thought the last week when I was trying to write a code for matrix multiplication. In fact, I was thinking about 3 for loops. You see, I was trying to figure out how I could compute C of ij, and I sort of messed up, if you remember. Messed up as in it was a long session. It was not clear on the mind. So I purposefully wanted to go slow and tell you people that your mind can get confused when the problem becomes complex, right? Functions, the idea of functions helps you stay organized. Number one. Number two is the idea of functions helps you write a small module, some facility, and frequently call it whenever you want. So it's like having a car and a car driver. Whenever you want to go somewhere, you just send a message and your car and your driver is ready. Right? So functions are like that. When you keep using the same routine again and again and again in your programming, it's good to write that block of code and keep it separately. And that's what your DEF facility gives you in Python. So let's go ahead and try to see if we can write a piece of code that uses functions, and let's see how simplistic matrix multiplication becomes. So what should we do in matrix multiplication? I need to initialize C to 0. Alright. I need to consider two matrices A and B. Perfect. I need to find the dot product of two lists, correct? And then I'm a little particular about putting full stops at the end of the comments. Okay, so and then what do? Let me think. I take the ith row of A and the jth column of B and figure out what is C of ij. Ijth entry of C is ith row of A dot product with jth column of B. So I need to pick ith row and jth column in a matrix. Okay, these are all small subroutines that we need to follow. I mean that we should be ready with. Okay, so what I'll do is I'll individually write code for these things. All right. So for example, define initialize a matrix. All right, and I'll say dim. Dim is the dimension. You will in a minute see what I'm trying to do. All I'm trying to do is I need a code here. Let's say on the terminal I'm typing. If I said C equals initialize matrix 3, then of course it will throw error here because you don't have that function ready. So what I want is I want your C to become something like this, right? 3-dimensional. Okay, 0, 0, 0, 0, 0, 0, 0, and then 0, 0, 0, and this should be your C. Okay, what went wrong here? List indices should be, you cannot assign it like this, you see. So you should I think you can assign it. What's going wrong here? Let me think. C is equal to A is equal to, oh, okay, so I see the problem. I'm so sorry. So let me just go to the scroll up so that you can see it. I made a mistake here. I did not put commas there. That's it. Okay, so these problems are pretty common. So I'm not going to edit these parts, just so that you understand that everybody struggles and stumbles, and that's how programming is. Right? Okay, print C. C is this. I want this initialize mat dim to do precisely that. What should it do? It should return a matrix with all entries 0. How do I do that? Let me think. So I want, if it's 2-dimensional matrix, it should be 0, 0, 0, 0. 3-dimensional, it should be 0, 0, 0, 0, 0, 0, 0, 0, 0, so on and so forth. For any dimension, this should work. Let me think. So I will initialize C to this, an empty list, and then I'll say for I in range dim, okay, C append an empty list, right? That's what I do, right? So before going any further, I do this. I first want to initialize this to boom, 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 right? So, and then I'll say a C of 0, append 0, 0, 0. You get that? So you have 0, 0, 0 here in C. That's what I want to do. I have done this in this line here. Okay. So I have switched on the video for this very session so that you can also see the expressions on the face of the programmer. All sorts of moods you can observe. Frustration, happiness. Happiness only comes at the end when the code runs without any errors. Until then, it's a lot of frustration. Okay, so you see what's happening here. The best part is I'm able to think slowly. I only want to think about initializing a matrix. I do not want to worry about matrix multiplication here because I have broken it into 4 pieces, which I have written here, as you can see. These 4 pieces, right? So I'm only worrying about the first piece right now. C append a small list, and then for every entry in C, again for I in range dim. Why do I do that? You will understand in a minute. I'll say C of I 0th entry, which is the first entry here, as you can see. This part, okay. I will append 0 here. How many times? As many times as the dimension of the matrix. The matrix is 3-dimension. If dim is 3, I'll make 3 entries of 0 here. I hope this works. The best part is I have done something right now. Look at the psychology of a programmer right now. Programmer has done something, and I don't have the patience to even check whether it works or not. The program way. Okay, I don't have to read every line of it. Whatever came to my mind, I saw on the terminal, and then I wrote a piece of code here. I can quickly check whether it works or not. Right? So let me try doing that. I'll come here. You know how to do this, right? So I'll say print initialize matrix. Let's say 3. Boom. There's an error. So what's happening here? It is initializing to 0, 0, 0, but it should initialize to 0, 0, 0. So where am I going wrong? So this code is not right. Correct? Let's fix this. For I in range, I include 3 brackets, and then I in range C of 1 append. I should do it, a few times. You see? Or maybe I could do this. So what will this do? This will, for every time I append something, C of I, no. Everything is perfect. Just that it should append a little more times. For J in range dim, for every entry, it should append 0, 0. That's it. So this one only appends empty brackets, and this one gets you into each one of those brackets and appends zeros in it, the dimension dim number of times. And probably there's an easier way to do this in just one line. Some of you can try it. I clearly see that you can actually do it in one line, but let us stick to this code. So return C. I hope this works. Let me come here, scroll up, and then say print initialize matrix. Boom, it works. So the best part is it works for any dimension. Look at this. 4, 5. Will it work for 2? Will it work for 1? Oh, it works for 1. That's a one-dimensional matrix, 1 cross 1 matrix. Okay, so 0, 0, 0, 0. Perfect. So this is the power of programming using functions. I call it the functional approach to programming, but then there's something called functional programming too. Alright, so you must be careful not to mess with both these terminologies. I like calling it functional approach to programming. So use functions to code. Alright, so now I look at this, the psychology of the programmer. I now have peace of mind. I need not break my head on what initialize mat does inside this, because the code is working fine. Okay, so what I'll do is I'll come here. I'll say code verified works perfectly fine on the test cases. Okay, so I like to say this so that it gives me confidence that I have verified it. Okay, so next I'll go to the next function, which is I need to consider 2 matrices A and B. I need to find the dot product of 2 lists. That's important. When you take the ith row and the jth column, you may want to find their dot product. Okay, how do you do that? How is dot product done? So let me just think. Dot product of 2 vectors, let's say U and V is what? You have a list U, have a list V, and you may want a temporary variable ons, where for I in range, see here I assume that U and V are of the same dimension, okay, of the same length. So that again comes from your matrix dimension. You see, pause for a second and then think what I'm trying to say. What I'm trying to say here is my dim will be len of U, because length of U is same as length of V, and U and V are simply entries in a matrix. One is a row, one is a column. That's how you compute matrix multiplication, right? So I will say dim equals length of U. Okay, so for I in range, range dim, I will say answer is equal to answer plus U of I times V of J I. Okay, so we are used to writing I and J. If it's I and I, mine gets confused. Okay, so this is what I'm doing. Component wise multiplication and then adding them. This must return right. Return, I would say ons. Again, psychology of the programmer. I quickly did the program, hoping that let's say if I assume a list, I would say x equals 1, 2, 3, and then let's say y equals 7, 1, 2. Okay, what's the dot product of this and this? Let me just write that down. Let me scroll up, and then maybe the font size is a little smaller on this side, but I cannot help, I cannot keep the font size big on both the sides, right? So print 1 into 7 plus 2 into 1 plus 3 into 2. I know you're shouting aloud saying brackets needs to be put. I'm going to put that right. Okay, so print so and so and so, and it's 15. That should be the answer. Let me just check. I'll execute the program and use the dot product function here. Let's say even you need not use print. You can simply say dot product x and y or u and v or whatever. 15, perfect. So my dot product function is doing well. I repeat. Certain things are important that we repeat them as many times as possible so that you're not confused. What is xy doing here, but what is uv here? Right? You might be wondering. You can put whatever you want here. In fact, you can directly put dot product of, let's say, two vectors 1, 2 and 7, 3. Okay, so this is 7 plus 6, which is 13. It shows 13. You can put whatever you want here. The variables here will be known to this part of the editor. X is so much, y is so much. You're simply passing x and y. They're taken as u and v, and inside the function the manipulation happens. Okay, all these sound like jargons, but don't worry, so you will get used to it with time. But the point is just this: you pass on the values of x, y, or alpha, beta, or me and you, or let's say elephant and a lion, or a cat and a dog, or whatever variables you're using. You just pass in there, and then it picks up from here. Then does the manipulation and returns the answer. So far so good. We found the dot product. We have initialized the matrix. I'm sorry, it sounds like a rant, sounds like a philosophical discourse, but this is required. We have to go slow, right? In a matter of a second, in a matter of, let's say, I can challenge that anyone reasonably good with Python can finish the entire code in less than 1 or 2 minutes. I can challenge, I can do it in 2 minutes, but on purpose, I'm trying to go very slowly, thinking every single step. Okay? Yeah, maybe I can do it in 2 minutes and then debug it for the next 20 minutes. I don't know. After closing this code, I'll try to see if I can erase everything and do it in 2 minutes. And after that, I'll brag. I'll not brag before I test myself whether I can do it in 2 minutes. Okay, so dot product is done. What do I do next? Psychology of the programmer. I wrote here that we need to pick the ith row in the jth column of the matrix. Okay, let me write a code, a piece of a function which picks the ith row and the jth column. Define, I'll call it ith row, or how do I put it? Row I. Let's simply say row I. Okay, I'll write a function for this. For column, I'll write another function. Okay, how do I pick row I? How do I pick row I? So what is row I? Ith row is 0th row or first row or second row, whatever it is, it should tell me. So how do I do that? I'll initialize a list L. I'll return this list, which is the ith row of the matrix. Okay, so what am I saying? I should put M, I, correct? The ith row of the matrix M, correct? Okay, so as you code only, you will realize you will start with a mistake and then you will converge towards error-free code. Okay, so in M, I would like to look at the ith row, which means L will simply be for I in range dim. What is dim? What is dim? Dim is the length of M. Correct? Dim is the length of M. You see, I'm stammering. I'm not very confident. This happens while you're coding. Sometimes I'm blank. I don't know what to do next. You have to again stare at the monitor, look at where you are, and then try to figure out what you're trying to do. Sometimes you may not be able to. Then you may want to go take rest or have a sip of coffee and then come back. So for I in range dim, what do I do next? I need to append into L the matrix M's ith row. Okay, so I think I should not use I here. I should use something else. Let's say K here. Okay, because I need the ith row, and my column will vary between 0 to dim. 0 to dim minus 1 rather. 0, 1, 2. My columns will vary. Row will remain the same. It's the ith row, but the columns will vary. Clear? Okay, good. So, however clear it is, Even if the code is wrong, if the output is right, I will not care. Right? So return L. Let me see if this works or not. No error. So far so good. So I will take my matrix. Let's say, let me take a matrix A, which is 3-dimensional maybe. Sorry, let me scroll up so that you can see it. 3-dimensional with, let's say, 1, 2, 3, 4, our favorite matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. We have been using it since our 12th standard days. Okay, so I will say row of M, first row, 0th row. Okay. Name M is not defined. Obviously, it should be A here. You see, I made a mistake. Here I use the variable M, but here I use A. So you should input A there. There is no matrix called M here. This part of, I am showing my hands. I should probably use my cursor. So this part of the computer of my compiler knows only A, doesn't know M. So this should give me the right answer. Boom! Yay! See, I told you, right, psychology of a programmer. There's a lot of frustrating moments, unhappy moments, moments, but there is also moments where you feel very happy. So here is a moment where you feel very happy. You can see the first row, wow, second row, excellent, third row. Yeah, compiler is not very happy because you went beyond the index. It's only 0, 1, 2. That's why it's throwing up an error. Now, you see, in less than a few seconds, I'll quickly write a code for column, which is jth column, let's say. Okay, I can even put I here, but I'll put J. It's easy on the mind. So it will be exactly the same. Dim equals length of M. Another advantage of, simply closing your eyes and coding, because if this code has something to do with the ith row, some minor manipulation will give you the jth column. You see, I'm confident I can do it. Let's see. So L equals, again, it should be the same list. For, again, it should be K, right? For K in range, dim, but then you append what? You append the kth row and the jth column. The column remains the same, jth column, and the rows change. If you're confused at any part of you watching a programming session like this, you must pause and then think. You should not go ahead with black boxes in your mind. Or better even, you should open a compiler and type the code alongside with me. Return L. I suppose this works. Let's see. Column of the matrix A, 0th column, 1, 4, 7. Wonderful. 1, 4, 7. Good. So, right? 1, 4, and 7 is the first column. What's the second column? Let's check. Second column. The happiest of all moments is when you write a piece of code, especially a function, and then validate it this side and it's all perfectly fine. 369, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. It must be right. Okay, good. So I am done with this. Now you see the marvelous magic that happens. Sorry for the exaggeration. It's indeed magical for me, at least, that in programming you can break the otherwise complicated piece of code into smaller chunks and then work on them. Right? Dot product is done, row is done, ith row is done, column, jth column is done, initializing matrix is done. What else do you have? I need to now multiply two matrices. Define mat multiplication, let's say, of two matrices, let's say A and B. Whatever you give here, this you will be using within the function only. The world outside this function knows nothing about those variables, A, B, or whatever you're using within the function. Okay, this is called scope of a variable. We'll discuss that ahead. This is not the right time to discuss a lot of jargons. This is the time for us to help you gain confidence in programming, and that's all I'm going to do right now. Okay, good. So I'm going to multiply matrix A with matrix B. How is that done? Firstly, I must initialize a matrix C. C equal to, before that, I must compute what is the dimension of a matrix. This matrix dimension would be, let's say, len of A. Why? Because A and B are the same dimension. We are assuming throughout this program, throughout this course, that we are considering only square matrices. If you consider what is called the rectangular matrices, the number of rows is different from number of columns, blah blah blah, a lot of complications. Let's not get there. You can do it. If you can do it, do this, you can do that too. Alright, so let's look at the simplistic case where we are in a happy world where we only encounter square matrices. So length of A will be equal to length of B, otherwise we cannot multiply them. Alright, yeah, we can in fact multiply square with a non-square matrix. We're making it complicated. Let's not get there. Dimension equals length of A. We know that A and B are of the same dimension. Assume it to be true, and then you see, when you consider cases, things get complicated. That's why we should take the simplistic model. And then what do I do? Why did I say L equals? Dimension is len of A, and then I need to initialize the matrix C. What is that? C equal to initialize matrix. What was the name of that function? Initialize underscore mat. Initialize underscore mat of dimension. Now you have C, which will have all leading zeros inside it. C is ready. Now all that you should do is look at this magic now. For I in range dimension, for j in range dimension, you must compute C of ij. That's all is your motive, correct? You must compute this new matrix C, which is the product of A and B. Perfect. So how do I do that? This is what I mean magical. Everything is ready for you right now. You initialize C. Okay, you can pick the ith row of a matrix and the jth column of a matrix, as you are seeing. Now I keep looking this side because this is the side where I have the terminal. I don't know in the final video where the terminal, where the program part will be for you. So I keep looking at this part and then I'm coding. C of ij is equal to ith row of A multiply dot product with jth column of B. Now what is that? What is that? Let me see. C of I'll delete the first line there just so that I'm clear. What is ith row of A? Row of A comma I, as simple as that. And then what is the jth column of B? Column B of J. Column B comma J will give you the jth column of B. Row A comma I will give you the ith row of A, and then you must now find the dot product of these two things. That's very, very, very easy. Is it really easy? It's easy because you have a function already kept ready. What was that function? I'm just to be accurate. Dot underscore product is the name of the function. Dot underscore product of row of A comma I comma column of B comma J will find the dot product of these two vectors. What two vectors? The vector row AI and the vector column BJ. These two are lists, you see, rather vectors. Vectors lists. In programming we call it lists. In mathematics we call it the vectors. I want to find the dot product of these two things. That's already done before. You see, the advantage here is that whatever you want to use, bits and pieces, you keep them ready, so that you can put all the pieces of the puzzle and you go hip hip hooray, right? So this should work. I suppose it does. If it doesn't, we'll be disappointed. But I suppose God is great and this will work. Okay, so return C, and there you are. I'll execute this. Invalid syntax because I had to remove this. This was plain English for my understanding, right? C of ij is ith row of A into jth column of B. You will not be doing it this hard if you practice well. One can go ahead and then quickly finish this in no time, but then I am doing it very slowly so that you can see how I'm thinking. So Cij is equal to dot product of row AI column Bj, return C, everything is done. I'll execute this. This should work. Thankfully no errors, as you can see. Now what was A? Matrix A is already ready. I'll take a matrix B. Let's say let me write a matrix, 3 columns, 1 2 3 4 5 6 7 8 9, and maybe 1 2 1 3 1 7 and 6 2 3. Okay, this is my matrix B. And then I will say matrix multiply A comma B. Let's see what it returns. It is returning a matrix. Very good. Hopefully this is the product of A and B. Let's see. Let me take the first row of A and multiply with the first column of B. What is that? It is 1 times 1 2 3 is the first row. First column of B is 1 3 6. 1 into 1 plus 2 into 3, am I right? And then 3 into 6, 25, perfect. So the 0, 0, C00 is 25, makes sense. So let me try to see if this is right. Let's say, what entry is this? Second row, third column of C, second row, third column of C, meaning second row, third column, we should not say that. I mean, 1th row and 2th column, right? Second column, because it starts from 0. 1th row is 4, 5, 6. I must multiply 4, 5, 6 with what? 2, 1, what is that? Third, the second one is 173 with 173. Am I right? That is my 57, correct? Let me just be clear. This is C of 1, 2, 1 A of 1, first row, and C 173. Perfect. I think I'm right. 4, 5, 6 with 173. I need to take its dot product. That's all. 4, 5, 6 with 173. Purposefully, I made a note of it so that I can type it easily here. 1 into 1 plus 5 into 7 plus 6 into, you would have done your arithmetic quickly. 54. It is 57. What's going wrong? 1, 5, 6, 1, 7, 3. I mean, what am I doing? 4, 5, 6 and 1, 7, 3, right? 4, 5, 6 and 1, 7, 3. I'm growing older. I cannot. 57. Okay, so 57. Perfect. It's 57 here and says 57 here. I think my. Okay, so if you're growing older, there's a better way to find this out. So I'll show you that. Import numpy. There's a built-in function to do this. Okay, as I tried showing it to you the last week. A equals numpy of mat of A. It converts A to the type numpy. B equals numpy mat B, right? And then C equals A times B. Print C. Let's cross check this with this. 25 times 24, 25 times 24, 55, 25, 27, perfect. It looks, look at this output 44th line and this answer. I have written the code that is built into the computer, into the numpy library function. Anyways, I told you we are not going to use this. Many things that we are going to do is there already. The point is to do it from first principles, from the beginning. So what is the moral of the story? Peacefully, let us look at the piece of code that we wrote. We have broken that matrix multiplication thing that was so hard there. Although English wise it was very easy. Take the ith row and take the jth column and multiply them, find the dot product. That's the entry of Cij. Okay, that very same English we have converted here into program, and the conversion was very easy simply because you took a modular approach using functions. So this is the power of programming using functions, using modular approach. If you break them into small chunks, there are two advantages. One is easy in your mind. Second advantage is that when you create a module, let's say like dot product, you can repeatedly use it. Then use the same code in multiple places. You can write a piece of code, keep it aside, and then you whistle and it comes to you, to your rescue, right? So I hope you liked the video. I'm sorry, probably my video was a distraction when I was trying to code. I don't enjoy keeping my video on when I'm coding, but I tried doing it only once just for maybe fun sake. Okay, so let's go ahead and see a couple more problems pertaining to functional approach to programming. Take care. Bye.